Okay, let's talk about half-life. We've used the term quite a bit, so let's one more time. Exponential decay is when the quantity is falling rapidly towards zero. Half-life is the time it takes for the substance to exponentially decay to half of its original quantity. So if we were using that formula, A of t equals A sub 0 e to the kt, and we're talking about being half of the quantity, we can then do half of A of t, or A of 0 equals A of 0. So we're dividing by A sub 0, not A sub 0, excuse me, change to blue. So 1/2 equals e to the kt, natural log of 1/2 equals the natural log of e to the kt, and this cancels. So natural log of 1/2 is kt. So this actually is two calculations. K would be natural log of 1/2 over, t is natural log of 1/2 over k, and k, if I can keep writing t, that'd be great. K is going to be natural log of 1/2 over t. Now, I want to point out one thing. You see the negative here, and it's natural log of 2. Well, natural log of 1/2 is the natural log of 2 to the negative 1. We could bring that power out front, so it's equal to negative natural log of 2. And that's why this is negative, and that's a natural log of 2. So you can do that as well. So how to find the half-life decay rate, right? A equals A sub 0 times e to the t. Replace A with 1/2, A sub 0 e, and then replace t with the given half-life. Solve to find k. Express k as an exact value. Do not round. The rounding error can be really bad here. So in essence, what I just showed you, k equals the negative of natural log of 2 over t, or a natural log of 1/2 over t. But this is probably easier to put in the calculator. That's going to be your k. So the half-life of carbon-14 is 5,730 years. Express the amount of carbon-14 remaining as a function of time t. So we're using A of t is A sub 0 e to the kt, and as just showed above, 1/2 of A sub 0 is A sub 0 e to the k times 5,730. So dividing by A sub 0, that divides out. So 1/2 equals e to the 5,730 times k. Natural log of 1/2 is the natural log of e to the 5,730k. So that cancels. So it's natural log of 1/2 equals 5,730 times k divided by 5,730. K would be the natural log of 1/2 over 5,730, as described above. Natural log of 1/2 is the natural log of 2 to the negative 1, which is negative natural log of 2. So you can do this as negative natural log of 2 over 5,730. So we could have saved all that work if we would have just used this formula here. So express the amount of carbon-14 remaining as a function of t. So the amount times t is going to be the initial amount times e to the negative natural log of 2 over 5,730, times t. And this is our expression, our equation. Okay, moving on to radiocarbon dating. This is a process to calculate the approximate date a plant or animal died. The idea is carbon is collected through normal living, eating things, that are ingested into the body, and so a certain percentage shows up as carbon-14, and that's the part that would decay. So by measuring how much remains compared to what the rest of the carbon is, how much is, you can get an idea of the decay rate. So or you know the decay rate, you can get how long it's been decaying. How to determine the age of an object given the percentage of carbon-14 present. Express the given percentage of carbon-14 as an equivalent decimal K. Substitute K in the equation. T equals natural log of R over negative 0.000121. And solve for the age T. So let's go ahead and do this next example about a bone fragment is found that contains 20% of its original carbon-14 to the nearest year. How old is the bone? So the 20%, our R would be 0.2. So we're doing time equals the natural log of R over negative 0.000121, which is natural log of 0.2 over negative 0.000121. And from that we get 13,301 years old. Okay. Let's talk a little bit about, there we go, calculating doubling time. So A of t is a sub 0 e to the kt, same formula. Now we're doubling it, so by doubling it, if we divide those a sub zeros out, we get 2 equals e to the kt. So natural log of 2 equals natural log of e to the kt, which is kt, because this cancels. I was asking the question, log base e of what is e to the kt, and it'd be kt, so that's what that is. And t equals natural log of 2 over k, and k equals natural log of 2 over t. So according to Moore's law, the doubling time for the number of transistors that can be put into a computer chip is approximately 2 years. Give a function that describes this behavior. So time equals natural log of 2 over k. So 2 equals natural log of 2 over k. So multiply both sides by k. So 2k is natural log of 2. So k is natural log of 2 over 2. So our formula would be a at time t is going to be the initial amount, e to the natural log of 2 over 2 times t. And that's it.